In this lecture, we will learn about the flyweight design pattern and how to implement it in Python. The flyweight design pattern is a structural design pattern that is used to reduce the number of objects created and to decrease the memory footprint and increase performance. It lets you fit more objects into the available amount of RAM by sharing common parts of state between multiple objects instead of keeping all of the data in each object. When do we use the flyweight pattern? We use it when our program must support a huge number of objects, which barely fit into the available RAM. Let's look at the pros and cons of using the flyweight pattern. The advantage of using the flyweight pattern is that you can save a lot of RAM, assuming that your program has many similar objects. The drawbacks of using the flyweight design pattern are that you might be trading RAM over CPU cycles when some of the context data needs to be recalculated each time somebody calls a flyweight method. Also, the code becomes much more complicated once the flyweight pattern is introduced. New team members will always be wondering why the state of an entity was separated in such a way. Let's learn how to implement the flyweight design pattern using Python code. Up at the top of the program, we will create a variable named red set equal to the string red, a variable named green set equal to the string green, and a variable named blue set equal to the string blue. Next, we will create a class named color. Inside of this class, we will define a print function that takes in the self parameter. Then we will create a class named red that extends the color class. Inside of this class, we will define a print function that takes in the self parameter. Inside the print function, we will print the string printing red to the console. Then we will create a class named green that extends the color class. Inside of this class, we will define a print function that takes in the self parameter. In the print function, we will print the string printing green to the console. Then we will create a class named blue that extends the color class. Inside of this class, we will define a print function that takes in the self parameter. In the print function, we will print the string printing blue to the console. After that, we will create a class named colorObjectFactory. Inside of this class, we will implement the init function that takes in the self parameter. Inside of init, we will set self.colors equal to an empty dictionary. Next, we will create a function named totalObjectsCreated that takes in the self parameter. Inside this function, we will return the length of self.colors. Next, we will create a getColor function that takes in two parameters, self and color name. Inside of this function, we will set color equal to none. If color name is in self.colors.keys, we will set the color equal to the value in self.colors at the color name key. Else, we will check if the color name is red. If so, we will set color equal to a new red object, and then set self.colors at the key red equal to color. Next, we will have an elif statement that checks if the color name is green. If so, we will set the color equal to a new green object, and then set self.colors at the key green equal to color. After that, we will check if the color name is blue. If so, we will set the color to a blue object, and then set self.colors at index blue to color. Else, we will print the string factory cannot create the object specified. Finally, at the bottom of the function, we will return color. Time to test our code. We will create a variable named colorFactory and set it equal to a colorObjectFactory. Then we will have a variable named color set to colorFactory.getColor with red passed in. Next, we will call color.print. After that, we will set color equal to colorFactory.getColor and pass in green. Then we will call color.print. Then we will set colorFactory equal to colorFactory.getColor and pass in blue. Next, we will call color.print. Then we will set color equal to colorFactory.getColor and pass in red, and then call color.print. Then we will create a variable named number of objects and set it equal to colorFactory.totalObjectsCreated. Finally, we will print out total objects created, and then concatenate that to the number of objects cast to a string. When we run the code, notice that even though we set the color 4 times, only 3 objects were created, thanks to the flyweight design pattern we implemented, which promotes the reuse of existing objects. In the next lecture, we will learn about the proxy design pattern and how to implement it in Python.